Lesson 11 is 6, adding and subtracting rational expressions. The first half of the lesson, we added and subtracted fractions that had the same denominator, which is very, very simple. And then we talked about finding the least common multiple. The least common multiple is really the least common denominator. It is your common denominator. So take a look at this first example. When we have two fractions that do not have the same denominator, the first thing we have to do is factor those denominators. Now, this is a binomial, it's already factored. The first one we can factor, they are both negative because that's a positive sign, so both signs are the same and they both must be negative, and I'm pretty sure it's 4 and 4. So take a look at this. Our two denominators are y minus 4, and just a single y minus 4. So our common denominator is going to be two of them, y minus 4 times y minus 4. So this one is fine. We don't have to change that first one. So y minus 14 is there. But over here, in order to make it a common denominator, I have to multiply this by y minus 4 over y minus 4. Because when I put it I have to multiply it by another y minus 4. And whatever I multiply the denominator by, I have to multiply the numerator by. Be careful though, because we have to FOIL it out. So we are going to FOIL it out, and we will get y squared, and then we would get plus 4y minus 4y, so those would cancel out, and then minus 16. Now, once you're here, you want to combine like terms if you have any. So we've got a y squared, and we have plus y and minus 31 all over y minus 4 times y minus 4. Now, after we get here, you're going to want to look at the numerator and see if you can factor it. Because if you can factor that numerator after you combine like terms, you may be able to simplify some of these factors in your denominator. Now, I can tell you right now, this is prime. There's no way I can factor it, so there's no more simplifying. Prime meaning I can't. There's nothing. I believe 31 is prime. The number 31 is prime, so there's no way I can factor this because 31 and 1 is not going to give me one difference. And that's my answer. Just incidentally, side thought, what's the excluded value? What can y not equal in this expression? Hopefully you remembered that you set them equal to 0. So y cannot equal a positive 4. Goodness, my brain's not working with my hand today. All right. Just not that we need to know that for this, but we shouldn't forget about that little thing. All right, let's take a look at the second example. And remember, the first thing we're going to do is factor them. I'm going to rewrite it here. So I'm going to factor this first one. So I've got t's on the top, and so then t squared minus 2t minus 3 on the bottom. 3 is prime, so it's a 3 and a 1. And since it's a negative 2, it's going to be negative 3 and positive 1. Plus t plus 1 over t minus 3. Now take a look at my two fractions. I have a t minus 3 in both of them, so that's great. That's what they have in common. This one has a t plus 1. So what I'm going to have to do is multiply this second one times t plus 1 over t plus 1, so that my common denominator will be t minus 3 times t plus 1. Now, could I have written that t plus 1 times t minus 3? Absolutely. Multiplication is commutative, so it doesn't matter. But remember, when you multiply these two binomials in the numerator, it's a FOIL, first outer inner last. So the 3t plus 2 in that first fraction stays there. Then I have a t squared. I have a 1t and a 1t, so a plus 2t, and then 1 times 1 is 1. Combine like terms, t squared plus 5t plus 3 all over t minus 3 times t plus 1. Now, again, look at that numerator. Can we factor it? And hopefully you notice, no, because the only factors of that 3 are 3 and 1. There's no number in front of t squared, and 3 and 1 would give you 4 or 2 if we have different signs. So there's no way we can factor that numerator, so there's no way we can simplify down any farther. And that is your answer. All right, so a little more complicated. We're going to practice 2 more of these before I cut you loose. Now this one is subtracting, so it doesn't change a lot, but remember, and you know what I'm going to do? The first thing I'm going to do is, instead of subtraction, I'm going to make it addition, and I'm going to change the sign of the, or signs, that's only one, because I only have one number in there. But if it was a binomial, change all the signs of that one. So now I don't have to worry about that negative sign. It's already with the -2, and as long as I keep it there, we're good to go. Okay, so take a look at our denominators. Factor. In this first one, we have 1 over, I can take a 2 out, and I have r plus 7. Now that doesn't really help me because it's still not the same as r minus 3. So believe it or not, it's pretty simple. What I have to multiply this by is, I'm going to go ahead and multiply and distribute the 2 in there right away, because I have to multiply it by 2 times r plus 7, or 2r plus 14 over 2r plus 14. And this one is missing the r minus 3, so I have to multiply that one times r minus 3 over r minus 3. So my common denominator is now 2r minus 3 and r plus 7. I'm not going to multiply them because you know what? I may have to factor at the end anyways. Okay, so this top one, pretty simple because we're multiplying it by 1, just r minus 3. This one, we are distributing the -2. So it's minus 4r minus 28. Combine like terms. We've got a r and a -4r, so -3r and -31 all over 2, r plus, 7 and r minus 3. I know I flipped them there, but it's the same thing. I only flipped them because I accidentally put plus sign instead of minus sign. Can we factor anything out of that numerator? No, because 31's prime. I can't factor out a 3, and so we're done. There's no way we can simplify that. All right, one more of these. Let's look down here. Getting just a little bit more complicated. So once again, you see that minus sign. I'm going to go ahead and get rid of it by making the 3, the numerator, the opposite. So let's factor this denominator. Take out a 4 first. So we got n squared minus 16. How does n squared minus 16 factor? It is n plus 4 and n minus 4. So our common denominator here is all of that, because this one only contains an n plus 4. So I'm going to write that down here. N minus 1 over n plus 4 plus -3 over 4 n plus 4 n minus 4. Common denominator is all of this, so I don't have to multiply this second fraction by anything. It already has my least common multiple in the denominator. But this one I have to multiply by 4 and n minus 4. And I'm going to go ahead and in the numerator, I'm going to distribute the 4. So I've got 4n minus 16. I did that because then when I multiply it by this binomial, I already have the 4 in there. Okay, so remember we're foiling. I'm going to put it together. I have 4n plus 4, n minus 4. Now, what do we have up here? 4n times n is 4n squared. Then I have a minus 4n, a minus 16n, a plus 16, and a minus 3. Combine like terms. Let's see. This is going to be minus 20n when I combine these two, and this is going to be plus 13. When I combine those two. So I have 4n squared minus 20n plus 13. Can we factor that? First thing I'm going to look is, can I factor out an integer? And the answer is no, because 13 is prime. So I can't factor out an integer. Oops, I don't know why I'm doing that. 4n squared. Oh, you guys, I'm sorry. n plus 4, n minus 4. There we go. That's my denominator. So I can't factor out a number. Could we multiply? Now I know my numbers are my signs are the same, so we're adding two numbers. One of them is either going to be multiplied by 4 and 1 or 2 and 2, and my only two factors for 13 are 13 and 1. So 13 times 2 is 26, minus 2, that doesn't work. 13 times 4 is way too big. It's going to be way bigger than 20. And then even if I multiply the 13 times 1 and 1 times 4, I'm still going to get 9. It will not work. I cannot factor. So this is my answer. Okay, it is going to take time, it is going to take patience, and you're probably going to need some assistance. Double check your answers with a partner or a friend of yours. Please use your time wisely. Come and see me if you need help. The answers are going to be kind of ugly, so anticipate that. Just work through it, okay? We're hopefully remembering how to factor and getting better and better at that. All right, good luck. We'll see you next time.